Hello.
Hello.
Let's play around with LLDB. So for context, there's this application called BWA MEM2. It's a bioinformatic application that handles alignment to a reference, and it uses a couple of neat algorithms that we might get into, but I guess the objective for today is to be able to compile this application, debug this application with LLDB, and using a test data set that I've curated, and kind of just inspect the code, see how it's going.
I thought of a terrible idea.
Oh, yeah?
I put a bug in the code, and
Oh.
then you have to find the bug.
But how are you going to do that?
As in, I guess I make a tweak, and then using LLDB and stuff, you got to work out what bug
Right.
was introduced.
Yeah, we could do that
But
in a future session, maybe.
it might be a good idea for some other content,
Yeah.
but doesn't make any sense here.
Mm-hmm. What the hell? What's all this?
Is that since you updated Mac?
Yeah.
You probably have a new version of Xcode.
Hit the return key. Do I have to, like, read all of this?
Yeah.
Did I just do it?
You have
Here we
to.
go. Sudo, and then retry this command. Sure.
You got to call the Apple hotline and recite back the license to make sure you know it, that you've read it. Then
Okay, here we go. Type agree. Sure, Apple. I agree. Anyway, so the first things first. There's a makefile part of this repository which we can look at, and I guess let's just make sure that we can make it. So the key thing that I'm looking for here is optimization turned on, and that would be here.
3 looks like.
So we can just disable that by setting this. And we potentially want every warning and every error coming up as well.
Okay. Do you have a watch thing going on the right?
I don't have it watching, no.
Okay.
It's just compiling at the moment.
Yeah.
Oh, it's taking a while.
There's a lot of warnings.
But if we look at the source, we can see that it's a C++ application. It has a main, it has header files, and if you just look at the main, we can see that it's a pretty small file. It includes this main.h, and now that we've compiled it, we should be able to see what it responds to when we run this binary. And we can see there are a couple of commands: an index command, a mem, a version, and already just inspecting this main CPP, we can see that it's taking the argv and checking if the value is index. If it's index, it's going into this BWA index. If it's mem, it's going into this this section here. And there's all this interesting macro if and if stuff, which we can look into what this means. But for context, this BWA MEM2 code is a optimized version of BWA MEM, which makes use of, say, like whether you're running an Intel compiler or specific architecture, and will, I believe, do some optimizations like with SIMD and all that stuff. We can read some of the details if we just go to the GitHub. It might tell us.
Not recommended for production use at the moment.
Yeah, so it says BWA MEM2 is the next version of BWA MEM in BWA.
80% faster, that's a big number.
80% faster? Yeah. And yeah, so it says that it automatically chooses the most efficient implementation based on SIMD instruction set available on the running machine.
Mm.
And
Yeah, I guess that's what the if-defs
would,
tell
yeah.
us. It's like that's how it knows which one to pick as the conditions.
Yeah. We can look into some of these macros, but yeah, so we can see that it was compiled with no optimization, which is good. We have symbols and stuff. So now that we have this BWA MEM2 binary, let's just run LLDB on it, and let's make sure that we can like set breakpoints and do all that cool stuff. So let's say we wanted a breakpoint in main, line 59. We could do breakpoint set file main.cpp line 59, and then if we want to run this, we can, I guess, just call run, and it would wants access. Sure. Cool. Oh, it's even color coded. That's nice.
Yeah.
It wasn't before I upgraded to Catalina.
Huh.
So
Upgraded LLDB.
yeah, that's good. That's what I wanted. That's the whole reason why I upgraded Catalina.
Lol.
Because I wanted the color coding.
Lol.
And it worked. All right. So
That, holy shit.
yeah, so LLDB comes with like an intuitive GUI that allows you to step through.
This is the TUI thing that GDB has, right?
Yeah, exactly.
Except probably not buggy.
Well, yeah, it's still buggy. Like if I start to up the windows, you can see that's already bugged.
I was doing so well before.
Yeah, but that's cool. If we want to actually run this application, we should probably figure out how to run this. So if we just exit this and see how to run this, it takes a prefix, which is optional, and an in-faster file. So I have an in-faster file here. Excuse me. And let's just see what it's going to do. So it's entering this FMI search. It's printing out some stuff. Taking a while. Do I have htop? I do. Nice. It's using up all of my CPUs, which is good. Not too much memory. This is a lot slower than before I upgraded to Catalina.
I see nice gradients in your CPU meters. I don't know if that's the compression or...
Like this. This is just a htop thing.
It's just htop?
Yeah, this is just a htop visualization. Yeah.
I think there's a sort of Moyer effect that causes it to have this nice gradient.
Oh, I see. Yeah, I can see what you're seeing, I think. I think that's just from her Hangouts session.
Yeah.
Okay, so what did it actually do? I think it creates all these files. But let me just delete all of them. And then let's see it actually do it again. So if I do BWA MEM2, oops, dot, yeah. So Fish is pretty cool where if it shows you the previous command, you can just hit right and it will autocomplete. But you can't do the control R thing.
Is it any previous command or just the last command?
I think it's just the last command that matches, the signature that you're doing.
The prefix.
The prefix, yeah.
Yeah. Can you scroll through them?
I don't know.
Like if you press up or something?
Oh, yeah.
You can. Yeah.
Nice. Okay. That's good to know.
I use that constantly. But for me, it's mapped to page up, page down.
Right, I see. So the index command creates all these files. And let's not go into like what these files are. We just know that it creates these things. So now that we know how to run it, we can debug it and I guess set the breakpoint again, BR, and let's run it, but with the argument index and with the data with that file. And I guess I'll just delete those files again.
So what is index doing?
It's creating index files from this original reference file.
Is this the FM?
That's right. Yeah, it's going to create a bunch of indexes that it's going to use for the other application that it has, which is called MEM. And this MEM application, which is saying alignment, will take an input like DNA sequence data file, and then that file will be a bunch of like broken up DNA segments that it will need to reference this main one in order to figure out where it's located, like which where in the genome each little individual segment of their own DNA goes. And then once it's aligned all that stuff, it constructs, the person's final DNA alignment file.
Okay.
Yeah. So in LLDB, you can run it with arguments. So this should trigger it to go into this branch. And I've currently got a breakpoint at 59. So if we start going in and stepping through this, we should be able to see it go into this section. So let's just go next.
So how are you doing this?
Pressing N to go next.
Right.
Yep. So we're in the index section, and we can see all the variables here. Unfortunately, some of the variables are memory location, but if I just step out of this for a second and want to actually get the variable, let's say we want to get one of these variables. So what I think I can do is I can do frv, and that shows me the variables. And if I want to print this variable, I can do print argv, and it will actually represent what the char star is, which is the location of this.
Cool. That's really good.
Yeah.
If you just printed argv without the star, would it just give you the memory address?
That's right. So I wonder if I could, so you can see that argv1 is index, argv2 is actually the data. And if we look at the other variables, so...
Oh, I see. Yes. So star argv is argv0.
That's right, yep.
Yeah.
So already I can see some stuff which I don't understand. Like there's this reference to rdtsc, which if we look into what that is, it's defined in this util.h file, and it's this static inline unsigned long method that takes nothing and will return something that does some assembly code because of this ASM volatile. So dot byte with this hexadecimal and this hexadecimal, what does that do?
I have no idea.
So if we look up assembly dot byte, what does this do? You can access it relative to a label that comes after the dot byte directive. Example, label. Based on the final linked layout of the program, maybe the dot byte directives will get executed as code. I don't understand this.
But so go back to the original question, because I think the person asking knew what the part does. They're asking a more complex question.
So while going through some C code, having inline assembly, I came across the dot byte with a dot at the beginning directive. On checking the assembly reference on the web, I found that it's used to reserve a byte in memory.
There we go.
But in the code, there was no label before the statement. So I was wondering, what is the use of an unlabeled dot byte directive or any other data storage directive for that matter? So it's reserving a byte in memory.
And I guess that's the value of the byte, perhaps?
Yeah. If we just maybe look up assembly, maybe it'll have...
Yeah, guide is probably. But this ASM volatile, like it.
Yep.
Got more. It's got that string and then a colon and another equals A.
It's like
No?
what is the syntax here for ASM volatile?
Extended ASM.
So here's the grammar.
Oh, here we go. Output operands, input operands, clobbers.
So we have this parentheses and then the colon. It's the assembly template. And then the colon says the output operands. And then we have some more parentheses that doesn't exist in this. Literal string that is a template for assembly code. It is a combination of fixed text and tokens that refer to input, output, and go-to parameters. Well, I don't think it's worth like understanding too much about how the assembly is working. All we know that is this function returns this unsigned long, which is generated via the assembly code. And that's what I was asking you about before, where if you intermix the assembly code, how do you intermix the assembly code with the C code that you're dealing with? And it seems like that this ASM volatile is returning an unsigned long, but
no, that's return X.
Yeah, but I mean, what is the X doing in this piece of assembly code?
It seems to be part of the input operands, whatever that is. Sorry, output operands. That's an output operand.
Yeah.
Whatever that syntax means. I have no idea.
But that's why I'm saying it's kind of like assigning into this output operand, which is part of this, right?
Yeah, whatever that means.
Yeah.
I have no idea.
I reckon if we look up RDS...
But the assembly isn't returning long from... That's just return X is doing the returning. The assembly is doing who knows what.
Yeah, so the assembly is doing something, but we're returning X from it. And my assumption is that they're linked somehow, because why else would you want to return X?
Yeah. Yeah, it does something with X. I'm not sure what.
Interestingly, this abbreviation, RDTSC, is referenced in this instruction, which returns the timestamp counter in EAX.
Ah.
So these are registers? Are they? Well, that's what...
Maybe?
Yeah.
You know you're in hackerspace now when you go to Skull Security.
Yeah, general purpose registers, EDX. Volatile general purpose register that is occasionally used as a function parameter, like ECX, EDX is used for __ fastball functions. Wow. Okay. I mean, I have seen this in assembly. I've seen EDX in this syntax.
Yeah.
And that would be saying move something into the register.
Yeah.
So we gather that this thing is returning a timestamp counter, potentially, since its name is RDTSC. It's an instruction that returns the TSC in this register. And what
Its
is
opcode is 3.1, and there's a 3.1 in there, OX31.
Oh yeah.
I don't know if that's relevant. Oh wait, sorry, opcode is OF31. Yes,
Yeah.
yes, that's yeah, look at that.
Yeah. So it's like directly accessing assembly to call this instruction.
I don't know what an opcode is though. Okay, the instruction code.
Hmm. So does an opcode translate to hexadecimal codes that translate to a specific instruction?
I guess so, yeah. It must be the number that the CPU sees to know what to do.
Hmm. Okay. Well,
Oh. Wow.
so all of this is to potentially get some time-related type stuff, timestamp counter, and it's minusing Tim from.
We don't like Tim.
We don't like Tim, except it's doing the same call again. So it's like the difference between 1 second.
It's counting how long 1 second is.
Yeah, in machine land. And
yeah,
since we're debugging, we should be able to see what that is.
yeah.
So let's
Oh,
see.
and if we break, then we're gonna completely break its yeah, we're gonna completely break its notion of time.
If we break, what do you mean?
Or if we're like stepping through slowly,
Right.
it's counting the difference between points in time, and so it'll include however long we wait.
Yeah, I mean, but I started here, so
Yeah. Then if you start before the assignment,
yeah.
you'll be adding time.
So is this sort of a difference in what measurement though?
So the RDTSC is like clock cycles or something. What's it called? Time.
Yeah, timestamp counter.
Stamp count.
But is that representative of some unit that we are familiar with, like millisecond or something, or is it just in a different?
No.
Right.
So what does it say? So, unreliable. Okay. Strongly discouraged use.
Well, that's not good.
Alright, so you shouldn't use this. Cool.
Okay, that's a red flag already. Why would they need this?
I imagine it was more useful a long time ago.
Yeah.
And it's more reliable, but yeah, it's saying like multi-core, hyper, whatever's the architecture is probably not compatible with making it accurate.
And if you look here, the actual thing that it's doing is measuring the overall time it takes to do this method call, which is what we did, and giving back it in seconds by converting it with this conversion, which is interesting.
Yeah.
All right, so let's step into this function. See? So where are we? We are in... Oh, it doesn't say what file this is in, so I'll have to like go into here. But
no, it doesn't?
I mean, it does say BWA index, but that's got an underscore, so probably not that one. That's the function.
Okay.
It doesn't say what file you're in. But if we start stepping through this, we can see that it's given the argc and the argv, which we saw. It's just passing it through. we also see that it's doing this while C get opt argc argv. So it's going to get the options for the prefix. That makes sense. Just keep stepping through this. I can't step through this. Why can't I step through this? Yeah, what's going on?
Oh no. What was that?
Oh, I think I just continued it and it's going bonkers. Oh no. Okay, let's just run again. GUI it. And step into here. Okay. So we didn't provide any prefix, so it's going past that. If opt_int +1 is greater than argc. What's opt_int? Opt_int is not here. So maybe let's...
That sounds familiar. Opt-in. I can't remember though.
Right. It appears though that it was given not in this section. So if we go...
I think if you Google it, you'll find articles about it. I think it's one of those C things.
Right.
POSIX things. Parse options.
Right. So the get opt, it's related to potentially get opt.
Opt. What do they mean? Variable is the index of the next element to be processed in argv. Okay.
Okay, fair enough. Yeah, and it is doing the argv thing. If we look at the stack frame, we can see that it's doing this. So I guess that gives you access to that. That makes sense. We didn't put any prefix. Okay, so now we go into this method. So let's step into that. Here we go. So I'll just get out of this for a sec. So the method signature for this takes a char fa. So if we just print fa, we can see it's the data file that I gave it as input. And the prefix should be empty, I guess. If we just print that. Oh, it's the same. Right. So if the prefix is not specified, it just basically is the copy of the file that you give it. Sure. And then it uses xcopen to open this file. Let's see xcopen. Xcopen is a hash define that calls this method, or just like we'll replace it with this method call.
What's func?
Func.
I think the name of the function you're currently in.
It's like a special thing that tells you that.
Yeah, there's line, there's file, there's func. Yeah. So at any point in your C program, you can just ask like what line am I on? What file am I in? What function am I in?
Oh, really? That's pretty handy. It's like, yeah, it's sort of like reflection in a way, but like given for free.
So this is one really big reason why macros are still used. So like in logging, you have a log macro because it can just inject the current file and line number into your log.
I see. So why would it...
That's what they're doing here, is they want to just inject the current function into that function call.
So does it give you the entire content of the function when you do this, or is it just like the name of the function method, or
the name?
Just the name. Okay. So the name of the function in this case would be this thing.
Yep.
So it replaces func with... Do we actually see this in the code? So, I didn't step into it, which would have been useful. So maybe
we'd be able to see it if we stepped in.
Yeah, so let's just set a breakpoint here. So go br set file BWT index, and then we'll do line 66, and then we'll just remove the other breakpoint list, I guess, and then run. Yep. Okay, so if we step into this, and then we just look at the GUI, so we see GZ, hold on, so we see sorry, so this is the function XCOpen. It takes an FN, and what we can see here is we have this definition, GZ verb. Oh, okay, it just went here. So I'm confused what the define did.
So it define just find and replaces.
But what is it finding replacing? The FN?
It find and replaces xzopen with EIR xzopen call.
Okay. And what about this func replace? Where is that in here?
So that's the thing that I mentioned. It's equivalent to the current function you're in.
But I don't see the name of BWA index build in here at all.
So it's passed in as the parameter.
So this is going to be passed in as the parameter to
the... That is where it got passed in, yeah.
Okay, and we should be able to see, now that we're in here... Oh, sorry, you're right, yeah. So it gets... And why would it need the name of this?
Probably for logging and whatever. That's a language beyond the...
Yeah, you're right.
Beyond the language.
I see. So because you can get the char star of the... Yeah, as you just said, you can define these macros to pass in specific strings that relate to where you are, and then within the code you can then log out this line, this function. Very useful. So the FN itself is the data? I would have thought this FN, this is file name, right? And then mode is read, which we can see R, and it's using this GZD open to do it. So what's GZD open? Is that like an inbuilt method that comes with something like C? I don't know.
gzip, I imagine.
So it's with zlib, right? Ah, okay. So if you include zlib.h, you get this. And then you open it similar to like you would in Python, where you just you give it a file number. What's that? File no. What's file no?
I don't know. You could step into it.
Oh yeah.
In LLDB, just step in.
It just so that's if you give it if you give it hash if you give it a hyphen, it goes into there. So that's for standard out.
Okay.
But still, what's file no? Who knows? And then it's calling GZ open, which is I guess another method call in zlib, I'm guessing. Yeah, we can see it's in zlib GZ open. And if we just see, oh, it's in zlib. Okay. Yeah, so return value. So now it's compressed file stream. Okay, so the thing that we're getting back from this is a file, I guess a file pointer. C has file pointers, right? C++. C.
As it has libraries, but that's more a POSIX thing.
Oh, okay.
Yeah.
I mean, it is saying that it's returning this gz file object, which is a file stream, which I guess is the file, the pointer to that the thing. I guess if we look at the actual, if we step through it and then see what we get back. So we are there.
What type we get back?
Invalid thread. Sorry. Oh, it finished. That's why. Whoops. Let's run it again.
So I thought you would have paused it paused the execution when you set the brakes.
Yeah, well, it did, but somehow it continued and like finished it, which I'm not sure how it even did that.
Do you think it's running on other threads?
No,
we haven't seen that.
We would see it here. This would tell us if it's on multiple threads.
Yeah, I don't know why it continued. You never told it to
like
continue.
to get out the GUI, I'm pressing escape. I'm not sure if that's causing it to continue or something. But look at this. The file pointer handle has a have, a next, and a pause.
Ah, gz file s.
Yeah, so that's the gz file struct.
Mm-hmm.
So is this a method call to get the next thing, you reckon?
It looks like a pointer to me.
Right. So it's pointing to the next, whatever that is.
It wouldn't show you any methods, like.
Oh, okay. Yeah.
It only show you fields.
I see. Okay, so we get our file pointer back, and then it stops. Oh no, I can keep going. So alright, so we have our file pointer with this, that made sense. And then it calls some clock function, which, why is that different to the other one? Who knows? Let's just have a look what this returned by just like printing t. Okay, it's a clock t, so maybe if I do print, requires
not a pointer.
Oh, okay. I just wanted to see what the struct was for this clock t.
Yeah, you want to go to definition of the type.
I'm not sure if I can, if it's an inbuilt function that's part of one of these. Yeah, let's ignore that for now. And let's see where we're at. So we're going to print that we're going to do some pack faster. Okay, fair enough. And then it's going to do this function. BNS faster to BNT seek. How useful is that name? Pretty useful. Okay, so where are we? We are in this. So if we go here, okay. I'm just going to close all the rest. It's a bit too much clutter at the moment.
Close to being called pasta. I feel it feels cheating.
If only it was called pasta, right? Yeah, faster pasta. I'm pretty sure that was a chain restaurant in around here back in the day. Pasta, yeah.
Okay.
Okay, so extern void seek reverse. Does that mean that you're getting access to a global function?
Extern void seek reverse. Yes, that's the function declaration that's happening inside another function. Okay.
So they define it here and they say, I want access to it.
Yeah.
So that means that they must have declared the header file to get access to it in BWA seek IO up here. I don't see it.
It doesn't have to be in the header file.
How would it know to, how does the compiler know to allow it to use it then? If it's not in the header file and linking.
Anything that's not declared static, like if you declare a a variable or a function, like a global variables, global functions, if they're declared as static, then they don't get visibility outside of that file. So by default, everything can be accessed.
Oh, okay. But the way it links, though, this would have to come first, right? Because otherwise, how would it...
no ordering to linking.
Right. I'm just saying that the content of this method is in here. So when the compiler like resolves this method,
so there are two stages of compiling. One's compiling all the C files, and then the next step is linking them together. So
I see.
yes, it has compiled before.
Yeah, I see.
Yeah.
In fact, I don't see this file. It doesn't exist.
Do we ever call this method?
That's a good question.
Because if you never call it, then doesn't matter.
It's
you're allowed to do that.
Sure.
The linker will just never attempt to link because you never call it.
Sure. Okay, so let's just recap this method call, which we saw in some file that I can't remember. This one. It took the file pointer that we generated, the prefix and some number. So this number is a 4 only, which does something there. The prefix we know that we don't care about, and we can see here that the file pointer fpfa would be the same file pointer that we got. So if I just did, say, print fpfa, we should see, that's exactly what we saw before. And then if we read the code, it's instantiating all of these things and then calling some initialization method ksig init. So let's get to that. And then step into here. Okay, so where are you, ksig init? Okay, it's going to this ksig init 2. How did it do that? How did the... And where is this ksig init 2? So I don't want the hash define. I want this one, which is in utils.cpp. How did it do that? How did it jump from this method call to this?
But where is that one defined? The first one, the one that called.
Well, it's called here. It's called here. Here?
Where is it defined?
Whoa. Look at this.
Go.
So, is this correct to say that it's going to replace this scope with something that you give to this thing, and this type with something? So if you look for this thing, we can see that this ksig init 2 is finding also a scope and a type.
ksig init 2. Okay.
And where's ksig init 2?
That they call it, with GZ file and error,
And look at this, ksig init, which takes the type T.
But no, the one that, so that's still another define. It still hasn't created the function yet. It gets created at the place that at LLDB pointed to.
Right.
So that's the macro that will create ksig init.
You mean this one up here?
Yep.
Yeah. No, I understand that. But because it's nesting all these macros, is it true to say that when you call ksig init, it's going to call ksig init2 with static, which is the scope that gets put into all of these?
That's right.
And so it's basically initialized this application to have static scoped. And maybe they wanted to change the scope to be something. But
that's not the one that we went to. We went to ksig init 2, which gave it an empty scope. See in LLDB. the macro call.
I do see that, yes.
Yeah, so it's not the static one, it's empty scope.
And that means don't put static, which means global, if it's potentially.
It has external visibility.
Yeah.
Yeah. Yep.
Yeah. Yeah. Yep. Yep. This is what I was saying. So let's say we step into.
So in theory, we should go into that other macro, I guess.
Well, it did.
Did you step in or step? Yeah,
Yeah, I stepped, and then it went back into this, and then we're here again.
Okay, so it's not going into the source code of KC. Okay.
It seems to just allow you to define ksig init to say what scope this.
What does that function do again?
Ksig init. So it allocates. So calloc allocates some address in memory that's zeroed out, right? Versus malloc, which doesn't zero out.
No. I think calloc means checked alloc.
Okay.
I think it means it does more checks or something.
Calloc allocates requested memory and returns a pointer to it. The difference between malloc and calloc is
you're right. Yeah. I suppose the C stands for clear.
Yeah, I guess so.
Yeah, okay.
And what's this ksig t?
That is a good question. I guess that's a struct somewhere.
There we go. There's the struct. So it has a k-string t name, comment. What's a k-string t? K-string t is
keep asking questions.
Is a size t lm and a char star s.
LMS.
Right. That's
Learning management
system.
System, yeah.
Don't you love the variable names? And
L is okay, so it's a string LMS.
Size t.
What?
Size t lm.
S is going to be the buffer. L and M, length, and then something. Who knows?
We'll see. We'll see what the debugger tells us.
Whatever M is. Oh yeah, we can see the values.
So this thing is going to be a struct of ksig t.
Printseek. No need to. Do you need to?
Yeah, I do.
Well, it was a pointer. Yeah, you're right.
So I have the name, which is initialized to 0, a comment. There was a comment, apparently.
This is a null string at the moment.
Yeah, I know, but I'm just seeing the contents. Yeah, so we have name, comment. Sweet. That's cool, I guess. So if we keep going, and then we see it's callocking a bnt t. It's a bnt seek t. What is that? BNT seek t. Where are you, BNT seek t? I'll just see if I can go to
Yeah.
So BNT seek t and BNT seek h, and it has an alpac, and n seeks a seed, and ends. Oh yeah, n holes.
Oh, but it's got a comment. It's n seeks.
Clearly that makes sense.
N seeks is how many, I suppose, and then this is the elements.
And look, it's got these ends is a struct of offset.
Oh my god, there's words. NMs.
It's like lambs, but NMs. GI. I assume it's the GI from GI Joe. And is alt
biology GI tract.
Oh yeah.
That's the GI tract gene.
Of course.
You can fit it in 32 bits. You knew.
Oh, and Anno. Isn't there a game called Anno?
Anno.
Yeah, Anno the ship game.
Do I have that game? No,
I don't know, but it could be that they somehow love the game so much that they just reference it.
Mm-hmm.
Okay.
Just a random reference. And holes.
All right, so this thing created a k-seq-t, a bns-seq-t, and then it seeds. It sets the seed to 11. That's important. You don't want to set it to 12. You want to set it to 11.
I mean, most people think 10 is the most, but 11 is actually the most.
And then it S-ran 48s on it. What does that do?
Seed rand.
Oh, okay.
48, whatever the hell that is.
But what file was that in? That was in
C standard lib. There's a rand library for random functions, which is terrible. Don't use it for anything important. It's low quality random.
Oh, really?
But srand is how you seed the random number generator.
I see. But so they're saying this is the seed I want, and then seed the random number generator. What's 48 mean then?
So they must have their own version of it.
Yeah, that's what I want to see. Like, did they write this? I can't seem to go to definitions, so it must be part of one of these libraries. Like,
yeah.
I can't tell.
All right. Maybe.
But look at this. They're setting ands to something. To a BNT and 1T. What's that? BNT and 1.
And 1T. Go to definition.
Oh, it was this thing.
Oh, is that thing? Is the anode.
Yeah. So if we next it, we should see the BNS. Can I do this? Yeah, I can. And then I can.
How do people program this?
They just like got amazing memory or something. Or
I mean, granted, like in Unix, Linux command line, it's full of the same kind of thing, and I guess you just learn it over time.
Yeah.
But like every computer, this is just a project, which I guess you just spend years working in, and so all these take on meaning.
But at least if you're gonna work on this, to the point where it has meaning, tell us what it means.
Yes. Yeah. Just
like
have translation at some point.
Yeah, I mean documentation or
glossary, basically.
Unless it's so like the fact that it's MIT licensed is kind of like a laughable thing because it's like, yeah, do whatever you want with it, but it's like you won't know what to do because I've made it so obfuscated.
Like it's not far from just being compiled assembly.
Okay, so this PAC thing seems to be a very special thing, and I believe if we actually look at the data, like one of the files is this PAC file, and I think that's what it's creating. Like if I actually get rid of the files and just let it do its thing.
Are they doing calloc mpac divide by 4?
Yeah.
What the fuck does that mean?
What's mpac? Do you remember what mpac was?
It's there in that function, just line 302 being set.
Oh yeah. So it's some number.
But like, isn't calloc like?
It's the size, and then, what was the signature? You give it the size, the number of items, right?
Oh, number of items. Okay, that makes sense.
Yeah.
Okay, got
it. So how much is that in terms of, what's that in an integer? Print mpac. There we go. Divided by 4.
Oops. 2 to the 16, I think.
Can I do like math in here? 5, 5, 5, 3, 6 divided by 4? Damn it.
Print.
Oh yeah. Can I do that? Oh no, wait.
Just print.
Oh yeah.
There you go.
So it's saying, give me this amount of calocs. We want this number of ones. Is that right?
1 byte.
1 byte. Why specifically this number? Let's just keep going. So Q is referencing the struct up here that it allocated.
Mm-hmm.
No. And does it have values? No, it's still zeroed.
Mm-hmm.
It asserts that the stir length prefix, what's prefix? That's, yeah, this thing is +4 is less, okay, so it's checking the size length of your data file, that it's not too long, fair enough, I guess. And then it's copying, does a stir copy into name? Where was name again? Name. Okay, so name is just some char array.
Mm-hmm.
And then they copy that prefix into there.
So that's what that check is for. It's because name is 1 kilobyte.
That makes sense. And then it appends the PAC to start writing the file. Cool. So next thing we'll see is that it opens up this thing to write. I'm just going to skip that. Okay, so now it gets into something interesting. So let's step into this while loop. What the hell? Oh, it's doing kseek read. Okay, so if we look at kseek read, we'll see some weird... Yeah, we see this thing that says, give me a scope, and then...
So we can't step through this stuff.
That's what I was saying, yeah. Like, how do you step through this?
I'm surprised.
So why even write it like this? In this define, aside from like the scope thing, which I kind of get, but why would you want to write it here as a macro? Is it because it's inlining and it's like faster or something?
The scope, I suppose, to make scope a parameter. It has to be a macro.
So that would mean that in the code somewhere we will see a call to kseek read that has a different scope.
Not necessarily.
Yeah, not necessarily, because it has to be... the scope is actually passed in this macro, which is passed in this kseek init2.
Yeah.
Which means, how do you even...
This library is you can provide different scopes.
But how would you do it in your code, like if you were in this section of the code, which is... Where is that code again? Here, I think. Yeah. So how would you define a different scope in here?
You just call that macro with a different value.
So you would just call kseek init2.
Oh, but you wouldn't actually, no, sorry. You wouldn't be able to, because that would be another definition of the same name, which would collide. So yeah, you can only call it with one scope or the other.
So it must be like a configuration thing that he's doing.
Yeah, it's to allow you to instantiate it in whatever form you want.
Right. And that's why I was saying that this kseek init2 is being given... well, it says static here. So how is it not static in here?
They're not calling that one?
Yeah.
Yeah, they're calling kseek init2.
Right. So to call kseek init... kseek init2. How does this get called in here?
Right. See the LLDB.
Yeah, and how does it resolve to call kseek init2 with this from this file? I'm still confused by that.
What file is that? That's in util cpp.
Yeah, so it calls this fet method, which then goes... what's in...
So LLD, yeah.
Oh, okay, sorry, right. Yeah. So it's because of this.
Yeah. Yeah, that's why it's not static. And that's why it has all these other types injected.
So the header file has defined all this stuff, including
but
this.
They don't exist until you actually call that.
Oh, lovely. Very lovely.
Macros, don't use them.
Okay.
Yeah, this is a good example of like macros on there.
And when I called next, it's doing some stuff. It's taking a while. It was up to this point where it's doing a while loop. Where
you did next on the while loop. That could be like the whole thing. While read is greater than 0, that means while it's reading stuff, which is presumably the whole file.
While it's reading stuff, add 1. It's like not going further.
You can't go into the add 1. Is that because it's on the same line? Is that why you can't go in?
Yeah, I don't know. It seems to have like... So maybe let's break it up. So if that's the case...
Yeah, we want to be able to like set a breakpoint there.
Yeah. And then let's just print F hello world. Is that how you do it?
Yep.
And let's breakpoint delete. And let's go br set while...
you need to recompile everything.
Oh yeah, thanks.
And restart the application.
Yep. Yeah, so what are your thoughts so far?
Pretty unreadable. But I guess we knew it would be like that.
Yeah. Okay, so this is happening because now it's adding these error checks, which it didn't have before. So having this will cause it to have problems. I don't know what f-emissive is.
I've seen it before, but I'm not sure.
Yeah, I just wonder how this person like debugged, like when they were making this. Like what was their process in coming up with all this?
I feel like you want someone who's comfortable writing C. And they'd probably be able to read into this a lot more than we can.
Yeah.
Probably like conventions and stuff.
But that means there must be some strategy there.
Yeah. Like idioms and things.
The strategy seems very unobtainable at the moment. What we're looking at. Okay.
Yeah, looking at those types, and it's just random letters all over the place in the macros. Yeah.
314.
And I can't tell if we've gotten up to the optimizations or not.
Okay.
Cool. So we should be able to step in. Nice.
So where is this? Okay, so this is returning a uint t. And okay, so if we look at the variables, and the current scope, we can see that we have seek, which is this thing, which is a k-seek-t. So let's just have a look at what that is. Yep. And this makes sense because if we look at the file that I gave it, oops, we can see that it's deconstructed this so that we have the name. S is chromosome 1.
So we've got length and M. M is set to something. So maybe this is like a substring. It's pointing to the original string. It knows how long it is, and it's saying we're at this point inside it.
Where the original string is this entire thing, you reckon?
Yeah, where L is like the length of the original string. That's just a guess.
Yeah.
M marker.
Well, we should be able to see the total word count of this, right? So if we just do WC-L, maybe?
I think that's counting lines.
Okay.
You want characters?
Yeah.
Just
Yep. Yeah, so that doesn't represent the total amount of characters. M.
Oh, M is bigger than L.
Yeah, I think L and M, L being length was a good guess, but I don't think that's correct.
Not right. M is bigger.
Yeah. But we've yet to see the loop, so it's where is the while loop? So we got up to the add one. The add one, let's get rid of that. The add one takes the seek, and it's doing a read of the seek. This k-seek read is reading maybe a portion of the things and giving back a k-seek-t type. Yeah, because this seek is of type k-seek-t, right? Yeah.
Okay.
So this read gives us back just this section, and maybe if we count the number of characters here, one of them might be one of these values. So if we just do, how do you just count the number of characters in Unix? Is there a way?
Oh, well, that's been elided, so you don't have the full set of characters there.
Oh, okay, so you think there's more?
Yeah.
But is it LLDB that's eliding it?
I think so.
So maybe I can do length of this. So if I do seek.s.length or something.
So can try. You need to do Sterling.
No member named. Seek is a k-seek-t. Do I do this? S? No member name S? What? Because it's under seek. Right. Seek. And then S. Dot S. Okay. And then Sterlen like that. Has unknown return type. Cast the call to its declared. Okay. So we want int.
Okay. Yeah, there you go.
Yeah, it's this. It is right. You were right. That's the length.
So M, who knows what the hell that is. Okay, cool.
And if you look at the file, like I'll swim it.
That first line is probably being ignored.
Yeah, there's a lot of ends. And then there's a bunch of stuff. And then at some point, if we go to line number, if we go to the
capital G.
But I know that's the end, but I actually want to get to this character. How do I just go through?
Press the number and then L.
Okay, hold on. Is it wrapping or is are these each line? I can't.
It's probably wrapping. I'm not sure. Actually.
So they're each line. Interesting.
Oh, okay.
So actually, if we just calculate how many characters are in here, so if we print, I don't know, int sterling 100. So 100 divided by how many characters is that? Print int. Actually, just print this divided by 100. So we get 9999 lines. So if we just move down to 9999, we should see the next line. 9999. Maybe not. I'm expecting. Actually, you know what? I should be able to see CHR, I reckon. Oh, maybe not. So what I expected was like multiple lines like this, and I'm not seeing that. So I think the subset that I got only contained one, which means that the while loop that we'll see might only show like one iteration, maybe? I don't know.
What do these segments mean?
Oh, you know what? I have an actual version that's a lot bigger. So if I go to yeah. Oh my god. Sure. Okay. So oh no. Data. References. Okay. Why is it so slow to like go into the folder? I don't know why it's taking like a few seconds. That's a bit weird. Okay, so this thing is 1.9 gig. I'll just make a copy. Alright, I don't need to make a copy because it's not actually modifying that. So I'll just copy this, LLDB it again, and then we'll run it with that data set. So if I go run index UCSC, oh, I don't have a breakpoint. BNTC 314. Yep, that's what I want. And then I want to run UCSC. Yep, run index. Okay.
Yep.
So if we next this, I'll step into it. Print seek.
That's a much shorter length.
It is. And if we keep nexting this, so we go, where are we? I might use the GUI for this. So we're in add 1. So what's the value of Bn of P? I want to see that.
It had it down below.
Oh, did it? What did I just do? That's okay. I can step into the next. Yes. Okay, so now if we print seek. Oh, we got something different.
This is much bigger.
Yeah. And if we do that again, so step next, we can start seeing some of these things. So let's just look at the GUI. Oh, actually, I'll just close this again. I mean, pretty not readable. It'd be good if you could just like convert this to the dereference version if there were pointers.
I'm confused at what I'm looking at.
Yeah.
Like the M6, it says it's an int pointer, and the thing we see is like a whole bunch of stuff. That's not an integer or a pointer.
Where is M6 defined though? It's passed in to this thing. So the call site passed that in.
I don't understand what the GUI is showing me. It's showing me things that are not integers or pointers.
Right.
Me all this string stuff.
So
here it's okay. The GUI was showing all kinds of. Maybe it's getting buggy.
And if I dereference it, it's an actual value 8. Well, yeah, that's just a memory address. Why is it showing all the hexadecimal weird stuff?
Yeah.
Very weird.
Yeah.
You know what? I think I know what it's doing.
Yeah.
But I'm just trying to get out of this section. I'm not sure. How do I step out?
Maybe U for up.
Help.
Oh, fin. In GDB, it's fin.
There's,
yeah, maybe up.
Yep. I step into it again. Okay, so now if we print C. Wait, is that the same one? Can't tell.
It seems different.
I just want to see the number. Right. So if we see, where is that? So that has a 243. Oh, it's the same one. So do I have to?
Did you go next?
Wait, so I stepped up.
You went up the frame, but you still need to go next.
Okay. But then it goes.
You just move your view up one step.
Right. But it went inside again. Into that add function, and I'm trying to get out of it.
You can't change where your hand is. Oh, really? Yeah, there must be a way to finish the current function.
Finish is executing. Oh, maybe finish?
Yeah, finish.
Let's try that. Finish. Okay, so if I step into it. Huh? It didn't step into it? Oh, whoops. I didn't want that. I wanted... No. trying to get out of this, Casey.
Finish.
Oh yeah. What's going on? Yeah.
You should do one of the things with Damien.
Oh yeah.
I reckon Damien would be able to read this.
Yeah, I reckon that'd be a good idea.
Damien would know how to go, what the methodology is for like understanding the code.
I somehow think that he will also struggle with this obfuscation.
Right.
Yeah. I think this is a good place to end.
No, I'm happy to have seen some LLDB.
Yeah.
See the DB and see its print capabilities. And the main commands to use is like setting the breakpoints, opening the GUI, printing values, going next, stepping, continuing, finishing.
I think like it's obviously nice if you have it in an integrated development environment, but actually having the full control is